Hi guys, I'm Architect Ron. I'm an architect and master plumber, and today we will discuss about a short introduction about BIM or Building Information Modeling and how can we use it and maximize its full potential on our every designs and projects. So what is BIM? So BIM is an ingenious and innovative process of accurately and spontaneously utilizing 3D software as database. So the perfect words here is accurate and spontaneous, as a BIM has its own way of collecting all the information accurately, use all those data and produce a very accurate model representing the actual building or the actual structure. So BIM has a very unique and accurate process of creating a 3D model, not just the model, all the information, all of the data of what design or what information you want to convey as a designer. So another word here is the spontaneous, as BIM also has this advantage of accurately updating all the models, all of the parts of the project spontaneously throughout the project. So if there are some changes late in the project, if you update the model, for example, it will be updated to all of the drawings, to all of the systems. That's the advantage of Revit. So sometimes people get confused about BIM is equals Revit. BIM is a process and Revit is a tool to achieve BIM. So we have a lot of ways of achieving BIM. It can perform all of the potential of BIM natively on Revit. So that is the advantage. So BIM is more of a process. It's more of a management of your design process. So if you have this potential of collecting all the data accurately and producing a very accurate model, and how can you coordinate all of those trades like mechanical, electrical in one model, then BIM, it improves the communication and documentation throughout the whole design process. As you can see right away, the effect of every movements or every design, or the every effect of the addition of certain building elements with reference to the other parts or other trades inside your structures. So it also improves the management accurately of the project from start to finish. In real life construction, we can use BIM starting from the design, development up to the project maintenance. So from start to finish, you can use BIM as all of the data and information are stored in the model in a very accurate manner. As a designer, we have a lot of ways to convey our design, either to your professor or to your client or to the general public. So we have this you can do it in a traditional way. We do manual sketching or AutoCAD, but you'll see that in BIM we can improve the process and we can do it faster, as BIM is a very accurate and a very spontaneous way of presenting your design ideas. Okay, but first let us discuss about what is the traditional way of doing things. So before BIM, the process is like we use AutoCAD or we use manual sketching. So the problem with this type of design process is projects information in multiple files and format. So in a design team, you have the architect, you have the engineers, you have the contractors. Each people have different files. So what if architect has changes. The changes will be on his or her files, and then the other trades, the engineering, the contractor, they need to update their drawings, they need to update their information after the architect is done with the changes. So as you can see, there's a gap between how long the architect can finish the changes, and then how long the other trades or the other contractors can update their drawings. So there's a gap between the process of relaying the information and updating the project throughout the whole project. There's a chance that you will miss some information. For example, one team member of the project, they didn't receive the changes, they didn't receive the information. So you have a problem that some of the drawings and some parts of the projects are not updated because we are working on multiple files and multiple formats. Unlike in BIM, you have only one file for everything, and you have one way of you have a one source of information for all of these trades. Also, in traditional construction, it's difficult to manage changes late in the design. For example, you have a construction and it's already ongoing, and then there are some changes. Like I said earlier, it will take time for other trades to keep up their drawings to every changes because they are a separate team, because they are separate. Unlike in BIM, all of the data is centralized. So if there's an update, for example, to mechanical, it will be updated throughout the whole projects. You can see the effect right away in electrical and structural in BIM. Unlike in traditional construction, all of those information are separate. So it's harder to manage in a traditional construction. Another is there's a risk of data loss during multidisciplinary action. So the problem with the traditional construction is there are parts that is not updated, or there are certain people who will not receive the changes. So again, if those small details, even the small details, they didn't receive those data, it will have a big effect to the whole project. Just like, for example, a simple sizing of there's an update about the thickness of the wall in the structural. If that data will not reach for example, the interior designer and for example the mechanical ducting, it will have an impact to the set out of the wall. It will have an impact to the distance of the duct to the wall, for example. So you have those risk of not coordinated project, as any changes will be in a separate manner. It is separate from the whole team. Unlike in BIM, every change will be updated throughout the whole model. And actual construction, if you have this risk of data loss, if you have this problem with the coordination, we will have this for sure we'll have this waste of materials, and there's a delay in the project, as if a part is not updated, and you see that there's for example there's a clash in the project as you review the model. Basically, it will cause, like, there's a waste of materials, for example, because some trades are not updated with the other trades. So you will notice late in the project that there are some parts not coordinated or clashing to each other because all the files are not coordinated in a single model. So you will realize, like, for example, you already constructed the duct on site, and then you realize that the pipe will punch through the duct late in the project, because the for example, the plumbing contractor, they received late the information that the duct is at this height, for example. So it will so the effect of this is we need to construct again the duct, or you need to reroute the plumbing or the ducting, a new layout. So basically, if you already constructed that, it will have a delay of construction because you need to do it again. Also, you need to break some walls again. So there's a waste in materials because everything is not coordinated in one model. So the advantage of Revit is all of the changes, all of the design of all the trades will be updated in one model, so you can see the effect of each trade to each other. So you can see right away before you construct it if there will be problem, if there will be clashes. So that's the advantage of BIM. Okay, so this is the concept of BIM. So in every project, we have a lot of trades, you have a lot of people talking to each other. They have all those ideas to produce this project, for example. And the challenge here is how can we be coordinated with each other, and how can we lessen the challenge here is how we collaborate to each other. Like for example, we have the architects, we have for the architectural, you have the interior designers, we have the structural design, you have the mechanical, electrical, plumbing, you have the contractors, you have the suppliers, and you have the owners. So all of these people have ideas, all of these people have inputs, and the challenge here is how can we manage all those information, all those data to be coordinated with each other to produce a very well coordinated model or well coordinated design that we can implement on site smoothly. So that is the challenge, and that is the advantage of BIM. As all those data from this different team or different people, we can collate it in one, we can combine it in one model. You can see here one BIM model. You can combine all of that. For example, you have a supplier for doors. This is the size of their doorknobs. This is the fire rating. You can get all those data and put it on the model, and that one model will store all those information. You can see right away the effect of those details to the other trades, as we are just working on the same and one file only. Okay, so having said that, these are the advantages of BIM. So it decreases reworks. So if you have a well coordinated model, if you have you can see right away side by side, where is the pipe, where is the duct, where are the rebars of the structural walls, what are the thickness, for example, of the finishing of the wall. You can see right away the effect. If I need to reroute, if there's a clash, I need to reroute some pipes, I need to thicken the wall so I can hide this plumbing pipes. You can see that right away before you construct it, because BIM, you are technically virtually constructing the building before the actual construction. So you can see the process, or you can see right away what are the potential parts that we will have problems. So that is the advantage of BIM, because it's like practicing the construction part. So you can build it virtually first on the BIM. You can see the possible problems, so it's easier to revise on the software rather than revising it on actual, because it has effect or cost implication and schedule implication. So that's the advantage of BIM. Also, BIM advantage is the quality engineering. As we can see the overview of the whole project, the advantage is for the engineering. You can see what are the advantageous areas, or what are the faster route, for example, for the pipes. As I can see the whole I have an overall snapshot of the whole project, the whole building, I can see like where are the most convenient way to put my pipe, so it can be faster to collect all those, for example, those waste. I can see that in the model, like for example, on this specific area, I can collect this certain amount of waste faster because I can see it in 3D. So I can also see like there are parts that is not really advisable to construct. So that's the advantage of BIM, as I can see it as I can see the whole parts of the projects at the same time. I can also improve my design decisions, as I can see the overall project. I can see where are the pipes, I can see where are the highly congested rebars area. So if an area is has a lot of rebars, I will not put all my pipes there, because I know that it has a lot of steel reinforcement. So so the advantage here is I can see the whole project right away, and I can improve the design because I can see the whole project, and I can see all the design trades at the same time. Another is the improved documentation. Like I said, BIM has a way of accurately storing all the data, and you just need to open one file, all the data is there. So once I open the data, I'm sure that everything in there is the latest, everything in there is accurate. So I have this confidence that all of the information I'm getting to the model, that is the latest. I don't need to worry about there's a file somewhere, or I have I have some drawings that are not updated, because I am opening only one file, and that one file can be used by all of the trades. So that one file can be used by the engineering, that file can be used by the contractors. We are sure and that we are properly documenting the project, as we are only working with one file. So that's the advantage. Another is we have a complete project snapshot, because BIM is not just 3D modeling. It has also a way of viewing the project in multiple views, like not just 3D but also with the other drawings. Like for example, you can do shop drawings, you can do sections, elevations, even schedules. You can produce that in BIM. So you have a better way of understanding the whole project, not just the 3D, but also to datas like bill of quantities. You have all of those information in one model. So later we'll give you an example on how accurate and how convenient BIM is. So again, it also improves coordination, because you only have one file to work on the whole project. So it makes life easier for the coordination, as I know for every change that I will do, I will see right away the effect to the other trades, so I can notify for faster. For example, if I add a wall here, I can see which trades will be affected, for example. So if I add that wall, the whole model will be updated. The other engineers can see the effect of that wall to their own trades. So it's so the coordination is faster. Again, also it enhances the customer or the user satisfaction, as using BIM. It's proven that the project is faster and smoother, as you can see all those problems before you actually construct the project. So once I produce a very well coordinated model, I'm I'm really confident that once we construct it, we can minimize the problems, and we can have a faster construction, as it is already coordinated before we even start the construction. And having said all of those advantages, we can say that BIM is green because we deduct, we can reduce the waste of materials. We can construct the project faster, so minimizing the carbon footprint. We can also study the project, like for example, sunlight analysis, wind flow analysis, load analysis. Actually, all of those analysis you can do also on BIM with certain plugins. So BIM is a very, very helpful tool to study carefully the projects, not just the clashing, but also in analyzing certain specific or special analysis you need for every project. So the idea here is building information modeling is you have only one file. You can also combine, and you can also divide the project in part. So you can do all of this using BIM. You can do sustainability analysis, multidiscipline coordination, construction documentation, visualize and stimulate, custom fabrication, conceptual design, and all of these details you can get it in one single model. So that's the advantage, because on one single model you can get all of this information, and you can do all of these things with confidence that everyone is on the same page and everyone is well coordinated. So let's check the potential of or example of BIM here. In BIM, you can do this clash detection. So as you can see, since all trades, not just the architectural and structural, you can also input or model the engineering, like the ducting, mechanical, plumbing, electrical. You can model that and combine it in one model. So from that point, you can early detect the clashes possible during the early stage of the project. So like for example, this one, you can see that the plumbing, the ducting, and the fire protection lines are clashing on a specific area. So you can notify the designers right away, like we need to move these pipes, you need to change the elevation of the duct, for example. So at the early stage of the project, you can adjust already the drawings, because in the traditional construction, it's just flat, it's just 2D. You just know where the duct is running, but you cannot check the elevation or the effect of each design decision to the other trades. But in BIM, you can see it in one view, all of those drawings and all of those information given by the engineer. So as you can see, you can check all the clashes, and you can recommend right away. You can solve the problem right away before it is constructed. So that's the advantage of BIM. You can do clash detection real time. So actually, if the engineers have recommendations, you can check for clash detection right away. You have this dialog box, for example, that the computer will compute for you all of the clashes in the project. So if you update the model with the changes from the engineers after they input their solution to the problems, the computer will, or the BIM will compute if there will be another clash, or those recommendation will solve the problem. So you don't need to visually check each part. BIM has this tool to check for you right away if there will be clashes. BIM can produce that accurate report. Okay, another is, since we are modeling accurately the sizes, the counts, the specifications of each trades, we can do, or we can produce a very accurate bill of quantities. So what is bill of quantities? Bill of quantities are the list of materials used in the project with the sizes and even the count. So BIM can produce accurately how many tiles you need, for example, how many concrete you need, how many rebars and its sizes. BIM can produce that report for you. So that's another convenience of BIM. Also, if you have changes in the design, like for example, you deduct a pipe, for example, in this area, this bill of quantities will be updated spontaneously and accurately. So that's you don't need to edit this one, for example, because the BIM will update for you. Since we are working with only one file, the whole report will be updated spontaneously for every changes you're doing with the model. Also, if we are working with one model, you can produce accurately the shop drawing. Since we are sure that the sizes are correct, we can take a portion of the model and then detail it. Then the sizes we are sure and we are confident that it is accurate as it came from one model. So all of the people or all of the trades inside the project, they can produce their own shop drawings accurately as they are getting the sizes from one project only, from one file only. Okay, so BIM also can produce a project monitoring and schedule. Since I already know the size of the project, the scope of the project, and I can produce something like this. Like for example, in actual construction, I can color code in the BIM what is constructed, what will be constructed next month. So I can produce a very accurate report to be coordinated with the owner, coordinated with the other trades. Like for example, I already poured concrete on this area, so I can notify the engineers that, for example, it's already poured, so we cannot do any more changes to that, to minimize the wastage or the delay of the project, because they know once they saw my model BIM that it's already constructed, they can consider that in their decision making if there will be more changes in the project, or if they have a special consideration to that area. So I can produce a very accurate report regarding what is done and what will be done in the future. So I can produce that accurately using the same model again. Since we have this model that can update simultaneously and accurately, we can produce a real-time as-built. So for example, you have this model, you already finished it, and then in actual construction, definitely you cannot assure that what's in the drawing will be done on actual. I can update the model based on what is happening. I can update the model based on what is happening on site. So the advantage here is that I can produce right away the as-built. For example, in real time, the column was moved like 1 meter from the grid. That's because there's a site consideration that I need to move that wall. So what I can do is I can update the model real time. Also, I can update that the column will be 1 meter from the grid, for example. So once I update the model, that is considered the as-built already. Also, I can check if the movement of that column 1 meter from the grid, it will have an effect to the other trades. Will I hit a duct? Will I hit a pipe? I can check that right away, as I can use the same model as an as-built. So if there will be more changes or there will be more consideration, I can check the model as an as-built reference for my decision making as as a designer to the project. So as you can see, guys, BIM is very, very helpful, as it is very accurate. It can help you manage your design process, and you can relay your ideas to the client, to your colleagues, in a very organized manner, as everything, all of the data, all of the information is stored in a single file. So that's the advantage of Revit. So having said that, I want you to feel, guys, what's inside of Revit. Okay, so this is the interface or the software of Revit. So just like AutoCAD, it has the same feel because it's the same Autodesk. Okay, so once you open the software, it will look something like this. So you have here the panel for the opening of projects. So this is the projects, and this is the families. Families is a term for like the elements inside the Revit. Like for example, you have a family of doors, family of walls. Basically, it's what you call the details or the elements inside the Revit that's called families. But the project is the whole package, the whole system. Like for example, the 3D, all the drawings, all the sheets. That's you can open that or modify that in this project tab. Well, the feature of Revit here is like these are the projects that I opened before. So unlike in AutoCAD, you can, once you open the previous file, it's just the file names. But in Revit, it has the snapshot of the last view you edited on that file. Like for example, these files I opened and modified before. This is the last view that I saved before I closed it. So like for example, this is the 3D view of the gutter detail that I edited and modeled using Revit. These are the sample projects. For example, I closed this file on the perspective view. So that's the thumbnail of that project on this project panel. So that's you have here the open, new, and then the templates. So open, basically that's you can open your file on this command. If you want to start project from scratch, you just click new. Okay, so open, you will open all your location for the projects. And then let's try to start from scratch. So I'll click here the new. Okay, as you can see, Revit has this options for templates. Templates are like, for example, what Revit is doing is Revit already prepared for us the possible views and all the drawings and details we need for every project. So because technically it's once you do a project, we all know that we need some elevation, perspective, door schedule. Revit already knows that we need that. So Revit already prepared those views, those details, those settings for us. That's why there's a template we can choose right away on how we want the project to work with. So for example, if I click this, there's an option here. So basically, as an architect, we can we'll use the architectural template because it has all the views and all the details that we need as an architect. Like what I said before, the perspectives, the door schedule, and all the drawings. It's already ready to use for us. So that's Revit is offering on this template. So we click on the architectural template, and then we have an option to do a project template or a project. So we're not doing a project template here because there's already a ready template for us to use. So I just click on that project, and then I click OK. Okay, so once you open a project from scratch, it will look something like this. So this is your command panel. This is the basic commands you will need, like for example the open, save. This is the synchronize button. I think I discussed this before. Like for example, you can work one file but multiple computers. So for example, I'm one of the team working on a central file. So what I can do is whatever I made changes on my computer, I just click this button to synchronize it to the server. So my other teammates can see the changes I made to the model. So that's another convenience and advantage of Revit, because multiple people can work on the same file, and then they can see the changes I made to the file, because we are working on one file. So this is my link to the server, to my local Revit, like what I'm editing here. Okay, so yes, so the dimensions, the tags, 3D view section, so all of that. This is the control panel. You can see like it is tabbed or categorized on whatever you may need to draw. Like for example, on the architecture tab, all of the architectural components you can see here. Like for example, the wall, the door, the window, components are like furnitures, elements, landscaping. You can see if your mouse will point there, it will tell you what can you do with that command and what element can you load with that command. The column, roof, ceiling. So we have a lot of details here. You can try to play around with this and then check what's the effect of each command. Okay, so the structure, all the structurals, as you can see, the beams, the truss, brace, it's all here. It's all here. So system is the utilities, like at the end, mechanical, electrical, plumbing, for protection. So you can see here the duct, flexible duct, pipes. So if you need those components, you can click on this tab and just click anywhere there, and then it will give you option to add those elements to your project. So the insert button is if you need to link, like for example, actually I can link other Revit files to this project. Even CAD, I can link CAD. So for example, I use this feature to, for example, I need to convert a CAD file into Revit. So what I do is I link the CAD to my Revit file, and then I can trace it. Since they are the same Autodesk, you can snap, or you can align your elements to the CAD drawing. So that's the advantage. So I can also import CAD, export. I can also insert picture. You can do that. So you can also annotate, since our work is not just modeling 3D. Like I said, drawings are a type of language as designers are using. So they can convey the message on how we designed it, not just by drawing, but also by the annotation. So I can add annotations like angles, dimensions, elevations, text. I can add the comments to the drawings. This is the tab, the annotate. We have a lot here, like analyze. You can check even the loads, the wind loads, other like the luminous, other plugins. You can check also the how well lighted the room is. There are a lot of plugins for Revit for you to do that. You have also the massing site. You can add the landscape, even topo surface, this one. So you can load, like for example, that one. You can load a topo to the model, so you can check how steep the land on where your project is resting. So you can check what areas needed some cut and fill. You need to put more soil to have a level. You can check it because I can load also here the topography of the site. You can also draw here the property line. Okay, collaborate. This is also working with with other teammates. The view, you can modify all the, if I needed to add elevation, sections, details, I can do that on this tab. Manage, it's more of the properties you need to edit for the project. So, for example, by default, Revit is on English because it's in the US. So what I do here is I click the manage and then I check the project units. Where's that? Project units. So as you can see yung project units, this is actually before starting any project, you need to check this one. Like for example, like I said, the default of Revit is English. So for example, as you can see, the length is their format is 15 inches. So if you type the dimensions here, Revit will understand that as you are typing in feet or inches. So you need to be careful, and we can change this one with, I click this one, and then I can change it to my preference. So for example, here in the Philippines, we are on metric. So mostly we draw it in millimeters. So I can choose millimeters. I can control the rounding of, since it's millimeters, we can round up to the to 0 decimal places. So and then I click OK. The area is square foot, so I can change that to square meters. The volume is cubic feet. I can change that to cubic meter. So and so on. You can modify this one before starting any project, so you know that you are working on the right sizes. So just click OK. So now this is the metric drawing. So we have the plugins here, the modify, the basic copy. You can move, rotate. This is the modify tab. On this part of the drawing, this is the properties panel. So as you can see, all the details of you're working on it is on this properties panel. So you can work on this is the working drawing, the working panel. So once you are working on the panel, you can see that the properties panel is also changing to whatever you're doing on the working panel. This is the drawing directory. So as you can see, all the views and sheets will be, you can see here, like for example, it's also categorized by, for example, floor plans. So all of the floor plans are located here. The ceiling plans are located here. Elevations, legends, schedules, sheets. So far we don't have any sheets, so this is empty. So whatever you're working on it on this part of the drawing, it will be updated on the properties and your drawing directory. So let's try. For example, an architecture part. If you click on the wall, as you can see, the properties also changes. And if you click this part of the properties, it will give you options on all the possible doors you want. Like for example, I want to use on this the 8-inch generic masonry wall. So I click that, and then as you can see, there's parameters for the walls. So the location of the center line, and when I draw, since if we are drawing doors, we can align it on the exterior, center, or interior face of the. And then the base constraint is where is the base of the wall if you draw it. Base offset, if you want it to be like, for example, the wall should be 600 millimeters from the ground floor, you can do that. The top is what is the constraint at the top level of the floor. So this is unconnected, but I can set it to, for example, up to level 2. So meaning, the wall that I will draw will be from level 1 to level 2 automatically. Okay, so there's other details here you can work on, you can play around. So let's try. So if I click on the working area, if you click on the working area, you can see that there are an additional information given to us by Revit, like for example, the length of the wall and the angle. So this is very convenient if you need a particular length and angle of walls you need to work on. If I need a very accurate length of wall, I can also type it on the keyboard. Like for example, I need to draw a 7 meter wall, so I can just type 7 meters and then click enter. So that's how convenient Revit is and how accurate it is. So for example, I need to also, you can notice that there's already a hatch for you. So this is the legend for example, 8 inches masonry wall. So you can adjust that and you can personalize that hatch depending on your preference. So that's another details you can work on in the future. So for example, I want to continue drawing the wall. So you can see it's not the walls are continuous. So for example, I need to draw here another here you can see I'm very confident that it's a perpendicular wall. You can see it's 90 degrees. What if I want to do it in maybe 1.5 meters? Just type it, click enter. As you can see, the corners of the wall are already merged. So you don't need to do in AutoCAD, you need to trim the lines to make it a seamless transition on the turning part of the walls. Revit knows that it's the same wall and they should be merged at the corner. So Revit already trimmed that for you. So save you a lot of time. So I can continue here drawing walls. As you can see, Revit is doing the trimming and then making it clean for you. So what if I need to do another type of wall? So it will be continuous until you click the escape. So I click the escape. So from, as you can see, the drawings, the properties is updated also. So it's not wall anymore. So the properties here is showing you the details of the floor plan. So in the floor plan, you can see it's not wall. So in the floor plan or the view, as you can see the details of the view. So this is a floor plan. The scale, you can see you can modify this one. For example, 1:2. So I can change it to, for example, 1:100. And then click apply. So this now, the drawing is 1:100. So I can click here at the wall and then I can choose another type of wall, like this one, a thicker one, 12-inch masonry. Okay, as you can see, I can also snap it to the end point of the wall before, and then you can see that it's updated. The thickness is updated. It's now thicker from the last time. Let's see. Okay, as you can see, it's the same hatch because it's the same type of material masonry. So you can modify the hatch per type of material. So you can continue working on the project and then you can close it. Okay, so you can add dimensions, for example, so at the center line and then the center, for example. So that's really accurate. I think we draw it a while ago, like 7 meters. I want you to check closely the dimension. So as you can see, it's the size of the text on the dimensions. We are here at 1:100. What if I want to make that 1:200? As you can see, the dimensions got bigger. 1:200 is a smaller scale. So what we do is if the drawings is smaller, you cannot read the dimensions anymore. But Revit adjusted the text height of all your dimensions right away once you change the dimension. So what if I use a bigger scale? Like for example, 1:25. As you can see, the text got smaller because the drawing 1:25 is bigger. So Revit adjusted the size of the details for you, even the hatch, as you can see. So Revit adjusted the text, the hatch scale, even the text, Revit will adjust it for you depending on the scale of your choice. So I'll get back to 200. Okay, let's check if this drawing is updated with other views. Like I said before, everything you modify on the certain window, it will be updated on the other views. So let's check on the, for example, the 3D. This one is the 3D view. Okay, so as you can see, there's already hatch pattern. You can also personalize this. As you can see that the height is consistent ground floor to second floor. To check that, I go to the elevation view. Like for example, the south view. As you can see, the level is level 1 to level 2. This one. So as you can see, it is consistent also. We said that the wall should be from base of level 1 up to level 2. So as you can see, it is updated to all of the views. So this is the floor plan, this is the 3D, and this is the elevation. Okay, so there's some, for example, I want level 2 to be higher. Okay, so I can do, kunyari, 4 meters. I can just type here 4 meters, and just click. Okay, as you can see, the walls get higher because the walls, we set it at as it is reference to the level. It's level constraint element because we already set it on the properties that it should be and always be from the ground floor to second floor when we are talking to its height. So as you can see, the height, it's updated there. Look, we are here at the elevation view. As you can see, the properties is for the elevation view. So again, the scale is 1:96. I can change that to 1:100. So the properties panel is always updated based on what window you are working on what element are you clicking. Like for example, this is the elevation window. This is the properties is elevation view. But if I click on the wall, the properties changes to the wall properties. So I can also modify here. For example, I click on this wall. I can modify here the walls also by properties, not just by the elevation, 3D view, and perspective. Also, I want you to notice that if I click an element on a certain view, it will be highlighted on all the views. So you know where is the element you are working on with the other views. So for example, this is the wall. This is the top offset. For example, I want that wall to be 1 meter from 1 meter below second floor. So I can type that as negative 1000 millimeter, and then just I click apply. As you can see, the wall is now 1 meter below the second floor level. So that's the convenience of Revit. I can modify the project in multiple views. I can modify it in 3D, floor plan, elevation, and even in the properties. So I opened here a project, almost finished project. So I just want to show you the how Revit works, or how can you work on the software. So I opened 4 windows here. For example, this is the floor plan window, this is the elevation window, the 3D window, and the door schedule window. So this is the same project, but I opened multiple windows with the same project. So I want to show here the advantage of Revit. Like, I can edit or modify the project on one window, but it will be reflected to the whole project. Like I can, if I modify the floor plan, I'm sure that it will be updated at the elevation, perspective, and even at the door schedule. So this is the advantage of Revit. Like you can modify at any views more convenient for you. Like for example, I want to edit this room, for example, extraction room 105. I want to add details there, but I want it to be updated to the section, or if I add door, I want the door schedule to be updated. So that is the advantage. Like I can modify the project to a view convenient for me. Like I can add the details there, and then I'm sure and I'm confident that it will be updated to all the drawings in the project. Okay, so let's try that. So for example, of course, as a designer, we start with the visualization at the 3D of how we come up with the details, the space planning, how it will look like. But for example, looking at this 3D, at some point I realized I want to add a door in this area because there's no access from this area. Then I want to add a door here. So what I do is, for example, click this icon, the door. So when I click it, it will give me options about what doors can be added to the project. So this is the properties panel. So when I click it, I click this one, it will give me options of all the possible doors that I can use to this project. So for this one, I can use, for example, a single flash door, flash vision, and then what if I want a double glass? So these are the sizes. Then I'll choose, for example, the biggest, and then I'll click it on the 3D. Okay, so as you can see, right away it is updated to the 3D. I added the door. If I zoom it, you can see that it has all the details, the frame, the doors, and it's already updated to 3D. What is amazing is that we can see it is also updated at elevation. So this is the same view. So if this side of the elevation is this one. So if I modify the 3D, I'm sure it will be updated on the elevation and even the floor plan. So let's check the floor plan. So this is that area. So as you can see, the door is updated also on the floor plan and the elevation as I updated the 3D view. But let's check if it is updated also on the door schedule. So normally the new doors will be updated at the last part of the schedule if you don't added the door tags, because the door tags will be in an ascending manner. So for example, this is, if you can, for example, to check, I click the door, and for example on the elevation, I'll check the door. The size of the door is 1830 to 134. So to check if it is updated on the door schedule, I click the door schedule. As you can see, it's on the last part of the door schedule. You can confirm that 1830 by 2134. So that's the Revit work. So it's easier for us architects to do a project, because you can see it is updated right away at an instant, the changes you will do in any views in the project. So for example, I want to add a door here, but I want to see it. So the best thing to do that is to add a section. So this is the icon for the section, and then I'll just drag and drop. Okay, so as you can see, I already made a section view. So to check what it looks like, I can just right click and then go to view. So this is the section view. If you click here the box, you can modify the extent of the view. Also, you can notice that once I do a section, the grid is also updated. So to confirm that, you can see that it's HIJ. So we go back to the plan. So this is the view. So it's looking on this side. So to check the grid, this is the grid. It's confirmed HIJ. If ever like you want to check the grid name without looking at the edge, because normally the grid bubble is on the outermost part of your drawing, you can just simply click the grid. Like for example, I'll just click this grid. As you can see, you can check also the name here. So it's grid I. So this one is another grid. I'll just click that grid. The name of that grid is J. So it's very convenient if you're working, like for example, you have if you're working on a project and then there's an instruction to you like modify the room at between H and J. So I don't need to go to the edge of the drawing just to check where's grid HIJ. I just need to click the grids. If I'm working on that on that small area, I just click on the grid so I can know, for example, that's grid 5. So I'll not be lost on the drawing. So that's another feature of Revit, very convenient. So you'll not get lost while working on the project. So for example, this is the section view. Actually, you can open multiple windows at the same time, but Revit, what is convenient for you? Like for example, this one, this is the elevation. And then what if I want to add a window on this room? For example, this room. So I'll just click the window here. Again, on the properties panel, I'll have options. So I will choose, for example, this small window. So if I add that here, for example, you can see that dimensions are also shown while you put the window. So normally, it in reference to the wall, because sometimes if we put some windows, we have a reference, like for example, the window should be consistently for example 1.5 meters off the wall. So you can control that, like for example here, that's 1 meter and then that's 1.5. So I'll just click it on the wall and automatically I already added the window. Okay, so definitely it will be updated in all of the parts of the drawings, even the floor plan. Okay, let's check. The section is here. As you can see, it's not reflect. This is the window. This is the window. If you click it, you'll see the details of the window, and also if it's highlighted on one window, it will be also highlighted on the other drawings, like for example the section. So you know what are you working on, because it's coordinated with all the views. So for example, I want to delete it on the floor plan. For example, I'm the floor plan and then I want to delete it. So I'll just, for example, delete it. As you can see on the elevation view, it's already deleted. So I don't need to go to the section view just to delete the same window. I can delete it on the floor plan. If you don't want to get lost about the windows, you can see at the upper part of each window the view of each window. Like for example, this is the floor plan level 1 and then the file name. So advanced sample project. So this is the section detail view. This is the section detail. Okay, this one elevation south. So you can see the name of the view, so you'll not get lost. So for example, I want to edit the north view. So I need to check first the elevation, the name of that window, so I'll be safe that I'm editing the right view on the project. So I'll just close that. So for example, on this, to show you again, this is the door schedule. What if this door that I added, you see that when I click it, the door schedule, it's also highlighted at the elevation view and the 3D view. So I know what I'm editing, because you can edit also on the schedule. Like for example, this one, this is the door tag 330. So actually you can count all the doors on your project. So I'm already at 330 doors, so you don't need to count one by one. Revit can count how many doors you have for you. So for example, I click on door 330, then I click here delete. It will have a warning. So Revit has this safety feature that for any deleted items, it will always prompt you with a notification like you are deleting something. Like you need to be sure, because it will be reflected to all of your drawings if you deleted something. So I just click OK. Okay, then as you can see, it is also updated and deleted at the elevation view and the perspective. So this is how convenient Revit is. You can modify the project in all possible angles. I can modify it on the elevation, the section, the 3D, and even the door schedule, or even the, for example, window schedule, even the blow-up details. You can modify the project on all views, and with confidence I can say that it's updated to all of the drawings. So sometimes if we modify a part of the drawing, we are not sure that it is updated in all of the drawings. But in Revit, once you modify an area, it's automatically updated to all of your drawings, and you don't need to worry like you missed something. So that's the convenience of working on a Revit. Actually, you can also, for example, you can also modify it on the, you can see it also at the sheets. So for example, this is all, you can see all the views and sheets on this panel. So this is the properties panel. This is your drawing directory. So in the drawing directory, you can see here that there is a tab for sheets. So for example, we have two sheets prepared here, the floor plan, the A1 floor plan, and the section sheet. So I click that floor plan sheet. Okay, as you can see, we already have the drawings plotted on the title block. So we can let's try if we modify also the model, and if it will be updated here at the sheet. This is the sheet. So let's try it, modifying it. This is the, what floor it is. I think this is the ground floor. So let's check on this area. For example, this is the lounge, the same area we edited a while ago. So this area, this wall, is this wall. So let's check if we can modify from the 3D view, and it will be updated here at the sheet view. Okay, where you will print it as a PDF or print it on your printer. So let's check. So let's go to the lounge. Then we go. As you can see, if I'm on the sheet, I cannot add anything. So that's another safety feature. Like the the sheet files are like the window. This is like the uneditable part views of your drawing. So normally, if you're on this part of the drawings, you are not really modifying the drawings anymore. You are ready to print it. This is you consider it final. So Revit added that feature, like you cannot modify it on the sheet to protect you from accidental deletion of some items or details. So this is a floor plan, but if I change the window to 3D, you can see that the parts, like for example the door is now clickable. If I click the sheet, so you can see it's not clickable. The door is not clickable. So I cannot add doors on the sheet drawings. But if I change to 3D, the door is now clickable. So I click that door. And then also another safety feature of Revit, it will prompt you some notification about if you forgot to save. So like for example, I think it is set to every 30 minutes. So every 30 minutes or 15 minutes, Revit will tell you to save. So sometimes if you're working on a project, you forgot to save, and then it's the project somewhat is corrupted, and then you lost what you worked in the progress of the project. So Revit will always remind you, depending on your preference, you can modify this one, how often you want to Revit to notify you to save or to remind you to save. So for now, this is just a sample project. I'll not save, so just click cancel. So I'm here at the 3D view. Okay, I want you to focus on this lounge area, on the sheet file, then go here at the 3D view. So I'll add door. So I'll click that to the wall. As you can see, the door is already added also to the sheet file. So on last minute changes, like I want to add a door on the, for example, I wanted to add a door on the 3D view, then I need to print it right away, it's urgent. I just add a door on your 3D view, and then I just go to the sheet file and then just print it. So that's the convenience, and that's how fast working on Revit. Like I just need to click somewhere on the I just need to modify any part, because in working on any project, there's a lot of revision, last minute changes. So once I updated a part of the project, I am confident that if I print the sheet files, it is updated in all of the drawings. So this one, I just can print it. Okay, so this is very convenient for yes, the students, the architects, and all people working on the design and construction. This is very convenient because you already know that the design process is a trial and error process. So as you can see, if I study the project on the 3D view, study it on the floor plan, like the traffic flow, I like for example, I need to add a door here, and the elevation, I think for example, I need to add a feature here because I want to add more design. So it's a trial and error. It's you want to modify your project on different angles of the, or different views, convenient for you to edit, like for example in the floor plan, on the elevation. So it's a trial and error. The design is a trial and error, and Revit is very convenient with that kind of workflow, because once I edit it on the one view, it will be updated in all of the views. So sometimes you have to, for example, on the for example this one, what if I added the door somewhere here, so as you can see, I added the door, or positioned the door position the door to my taste. Like for example, I want it to be on close to the right side of this wall, without knowing that upon checking on the floor plan, it's already highlighted here at the elevation, so it's also highlighted in the floor plan. So once I modify it in the elevation, I can check what is the effect of that door addition to the floor plan. So as you can see, the door is conflicting with this wall. So it's that's the advantage of Revit. Like I can try and error about the position of architectural features. For example, this door, if I added it here, I can check to the floor plan what is the effect of adding that door. So I know from this example that adding that door on this area is not possible. So you can test and you can check and you can study better your project using Revit, because you can test all the positioning and you can test all those all your design to the project. I want it to for example, I want to add a column here. What is the effect on the room, on the floor plan, and even the perspective. So you can check right away in multiple windows. So what I do, I normally work with I open multiple windows while I'm working, so I can check what's the effect of any design decision I'm doing to the project. So as you can see, you can also add like windows, roof, and other details from the project. And I am sure that all of the changes I made in this project will be updated to all of the views and all of the sheets of the project. So this is the advantage of BIM and Revit. So that's it, guys. So I hope you learned something new, and I hope you will use this BIM in creating your designs and your projects. So